Consider the following linear regression problem. The problem states that police sometimes measure shoe prints at crime scenes so that they can learn something about the criminals. So listed below, you've got the shoe print lengths along with the foot lengths and the heights of the males. We're going to first investigate the foot length as compared to the shoe print length. So if we go and we enter the data, we press Stat and Edit. And if you'll notice, I've already entered in L1 and in L2 the shoe print and the foot length, both measured in centimeters. So if we're going to look for the least squares regression line that expresses the foot length as a function of the shoe print, this indicates that the shoe print will be the input and the length of the foot will be the output. So we're going to use L1 as the X values and L2 as the Y values. So we'll begin by pressing Stat, arrow once to the right for Calculate, and then we'll choose number 4, Linear Regression. Oops, sorry about that. Stat, once to the right, and then we'll arrow down. Choose 4 for Linear Regression. My X list is L1, my Y list L2. So I'm going to arrow down and calculate. Notice here that my linear equation, my least squares regression line, has a slope of 0.56755, and I've put it right here in the equation. It has an intercept of 9.11. I placed it here in the equation. So my least squares regression line from this data is y hat equals 0.56755x plus 9.11. So if we were to use this regression line to estimate the foot length of someone with a shoe print of 30 centimeters, we would simply plug in 30 for the value for x and then compute, and we would get 26.1 centimeters. To investigate a little bit about the strength of the linear relationship, we're going to look at the correlation coefficient. Notice here we have R is equal to 0.82786. I've just rounded it to 0.828. All right, this indicates a fairly strong linear relationship. Perhaps it could be stronger, and it may not be to the strength that we would like from the table. If we'll notice over here, table A6, this is the Pearson correlation coefficient table, and it indicates for a sample of size 5, which we have here, we would like to see a correlation coefficient of 0.878 or greater. Well, in this case, we have 0.828. In any case for this small sample, I'm going to assume that this is a reasonably strong linear relationship, and I feel reasonably comfortable with the prediction that we've made. 30 inches is well within the range of the input values that we use to create our model. Also, if we'll note the coefficient of determination, this is the R squared value, 0.685. This indicates that 65% of the variation that we witness in the foot length is explained by the regression line. So there are other things that may affect the foot length, but the information that we gain from the footprint length does account for much of the variation. So this is just an example of how you could use linear regression to model the relationship between two variables and possibly use one value to predict another. Thank you.